Hello everyone, we are going to see a case study on replacing overhead lines with underground cables in Finland. This case study considers a Finnish example of replacing overhead lines with underground cabling. The same strategy is also applied in other European countries. Elenia is the second largest electricity distribution system operator in Finland. To adhere to the outage requirements of Finland's updated Electricity Market Act, distribution system operators such as Elenia are investing in underground cabling. This is in line with expected impacts of climate change, including increased frequency and intensity of precipitation events, as well as growth and age of trees relating to increasing temperatures. This results in higher amounts of deadwood. Temperature increase due to climate change is expected to cause tedious trees to remain in leaf longer, and this increasing the risk of falling trees and resultant damage to power lines. So in many cases, underground cabling efforts have been aligned with the installation of fiber optic cables by telecommunication companies, and this is called co-construction efforts, and this leads to cost minimization. And Elenia has a target to achieve 75% of underground cabling of its network by 2028. Underground cabling contributes to climate change adaptation of the energy system, resulting in secure energy supply. So there are challenges also in the case study, and because the collapse of power cables causes temporary loss to power to the users while generating additional operation costs for power providers. In Finland, both storms and also precipitation are expected to increase in line with climate change. Snow precipitation can also accumulate in overhead lines, causing damage, breakage, and power outages. So, whether the direct impact or indirect impact, storms can also cause damage to power lines, resulting in power outages. Furthermore, storms can often increase the rate of lightning flashes, a further cause of power outages through damage to power lines. So, because of considering all the factors and in because of considering all the factors, so this Elenia this is started to for underground cabling instead of overhead lines. So the objective is to adhere to the outage requirement of Finland's Electricity Market Act and to adopt increasingly frequent and extreme weather events. So the distribution system operators such as Elenia are investing substantially in underground cabling. So since 2019 it is started. So there will be developing weatherproof distribution lines including underground cabling. So the weatherproofing efforts aim to improve the security of supply and also to promote local employment for underground cabling work for the period in question. Currently, 41% of the company's cabling is underground with a 75% target in 2018. And if we see the adaptation of options implemented in this case, and underground cabling is viewed as a technique of adapting electricity transmission and distribution systems to climate change, since it protects assets from expected climate change impacts including storms and excessive snow loads. And the installation of underground cabling involves three predominant techniques. One is placing cabling in correct reinforced troughs, placing the cabling in underground tunnels also, and sometimes directly burying the cables is also another consideration. In Finland, the technique used involves the construction of trenches ranging from around 0.45 meter to 1 meter depth with the cabling then buried within the soil layer. And there are cases mainly developed and implemented because of other policy objectives but with significant consideration of CCA aspects. And in the stakeholder participation is also available. Illinois representative suggested that the construction of weatherproof networks was a long-term process requiring opens and interaction both the operational purposes and to create trust toward the long-term change. And Elenia involves different stakeholders in different phases of construction as much as possible. And there is a key success factor for underground cabling is the availability of the correct technology for underground cabling. With regard to the installation, monitoring management also involves. So Elinea cooperates as much as possible with underground cabling entities such as telecommunication companies to minimize disturbance to populations through digging activities as well as reducing costs through collaboration. Although underground cabling could be exposed to a new climate hazards, in particular from flooding and also soil movements related to landslides, so far this risk remain hypothetical. And cost and benefits, there are social costs and benefits of underground cabling as a key adaptation measure was under review. And implementation time, the share of underground cabling in Elinya's electricity network increased from 38% to 41% in 2007, and it is expected at 2018 the 75% target is over. And see the lifetime, it is difficult to establish the exact lifetime of the underground cables that Elinia is currently installing, since none have yet reached their end life. The technical lifetime of underground cables is estimated to lie between 50 to 70 years. The regulatory or economic lifetime may be slightly shorter. Thank you.